All right, so section 6.2, properties of exponents. So I'm just going to be blunt on here, and this right here, there is a lot of little definitions that you don't have really much of a choice other than understanding. I'm not really too worried about you memorizing these different terminologies. I do want you to know the principle behind it. So this one that says product of powers property. It says to multiply powers with the same base, add their exponents. So I have this. It says 4 to the 6 times 4 to the third equals 4 to the 6 plus 3, 4 to the ninth. It's a very simple rule. And notice in the algebra, I have both of these have the same base, and when I'm multiplying it, I just simply add the exponents. So let me show you why this works. So I'm going to do a little scrap work over here. I'm going to pretend I am doing, because I'm going to do it on the side here. I'm going to pretend that I am multiplying a to the second times a to the second. Well, remember your rules of exponents. A to the second is really saying a times a, and then this is going to be times a times a. Well, a times a times a times a, and since they're all multiplying it, is a to the fourth. Well, that's the reason why we can just say a squared plus 2 equals a to the fourth. That's the reason, is when we write it out all logically, it just works. And the same thing is happening with us in division. It's the same concept, but instead of adding the exponents, we are going to subtract them. So, for instance, let's say I have a to the third and I'm dividing by a squared. Well, I can really say a times a times a over a times a. And I can simplify this. These two will cancel out, these two will cancel out, and what's left is just a. Or I could have said a to the third divided by a squared is equal to a to the third minus 2, which is equal to a to the 1, which is just equal to a. All right? So just a couple of rules. And then we have the next one is power of property. So we'll do this one. Notice that it says 4 to the 6. When all of this being raised to the third, we actually multiply the exponents and we get 4 to the 18. So if I were to do this, a squared, and I raise it to the third, the answer would be a times to the second times 3, or a to the 6. And this is why it works. I'm saying a squared times a squared times a squared. I am multiplying this by 3 times. And since I know this, I can use that rule of adding my exponents, and I still get a to the 6th power. But these are the basic rules. If you're multiplying with the same base, add the exponents. If you're dividing with the same base, you subtract the exponents. If you're raising a power to a power, just multiply the exponents. All right, so those are some basic rules. Here are some more rules that you need to know. This is called a power of a product property. If I have something in parentheses like 3 times 2 and I'm raising everything to the 5th power, this is very much like the distributive property. I'm going to raise everything inside of that parentheses to that 5th power. So it becomes 3 to the 5th times 2 to the 5th. So giving another example, if I have, I don't know, let's say 3a, and that's being raised to the 2nd power. I'm kind of using the distributive property, or in this case, it's called the power of a product property, and that's going to give me 3 squared times a squared. Well, we know what 3 squared is. That's going to give me 9a squared. All right? And then the same concept happens in division, where if I'm dividing, it's still raising everything to that power. So notice this, 3 divided by 2, all raised to the 5th power. I'm basically going to go 3 to the 5th, divide by 2 to the 5th, using that power of a quotient property, which is, again, like I said, very familiar to you. It should seem like the distributive property. Now, there are 2 more properties that you need to be aware of. One is probably tends to be the most confusing. It's called negative exponent. If I have a base and I'm raising it to the negative power, I have to rewrite it as 1 over AM. And the reason being is this is just one of those things in math. We get negative exponents, but we don't like negative exponents. So what we tend to do is if we have it like this, we rewrite it. And it's the same thing. Let's say I have a fraction and a to the negative m is in my denominator. I rewrite it. And let me show you how this works. A to the negative m can be rewritten as a fraction like this. But because of this rule, and I don't like negative exponents, I always rearrange it. I bring this whole thing down to my denominator, get rid of my negative side, and then I leave the 1 up top. All right, and it's the same thing with here. I have 1 over negative AM. I don't like this in my denominator, so I bring it to my denominator, and that leaves me a 1 in my, I bring it to my numerator. It leaves my denominator as 1, and I can rewrite it as a to the m. All right, now, I will be absolutely blunt. This is a lot of information for you to take in a very short video. So we're actually going to spend a few days on practicing just this stuff. This is a lot of information thrown at you, are these rules. So let's go over a few things in this video, and as you progress into this particular section, the problems are going to get a little bit more chaotic and a little bit more crazy, but for now, they're not. I will show you something of more of a coming attraction later, but let's go ahead and hit some of these problems. I know that this says m to the third times n to the sixth. Well, since I have both of these are my same basis, it gives me that power of a product of a powers property, where I'm simply going to add my exponents. So m is equal to 9. Or not, excuse me, m to the 9th power. I said that wrong. Now this one is division, and it goes to my quotient of powers property. And that's really saying t to the second minus 4. And when I do that, I get t to the negative 2. Now this is correct, but remember there's a statement in there that I do not like negative exponents. So I have to rewrite this. Remember, technically this can be written as a fraction. And that means that this that's in the denominator, I'm now going to put, in the numerator, I'm now going to put in the denominator and get rid of the negative symbol and leave my 1 up top. So now I have rewritten it. All right, this one, we have 3 to the third, all of this is being squared. So this follows the power of a power of a power property. So it's saying 3 raised to the third power times 2, and this will give me 3 to the 6th. All right, now the next one, we have h to the 6th times h to the negative 8. This is our product of powers property. So I'm going to go h to the 6th plus a negative 8, because since they're multiplying, we're going to add. And when I do, I get h to the negative 2. And now, because of that rule, I do not like negative exponents. I can know that this can be written over 1, and I can rearrange this. I take this from the denominator, I put it to the bottom in my numerator, drop the negative, and I leave a 1 up top, and I'm done. The next one, 4p all to the 4th power. This is a power of a power property. So it's telling me to basically kind of like that distributive property, I'm going to go 4 to the 4th power and p to the 4th power. Well, let's find out what 4 to the 4th power is, and we can use our calculator to help us with that. So to do that, turn it on first would be useful. I'm going to put 4. And then if you look at your calculator, there's a little housetop looking button. I like calling it a housetop because we're getting ready to raise the roof. We're going to raise this to a power. So we're going to hit 4. I'm going to hit that raise button, and then I'm going to put 4 in there. So I'm going to raise 4 to the power of 4, and I get 256. All right, and that's it. Looking at the next one. The same concept is a power of a quotient property, and what we're going to do is we're going to basically say y to the 3rd power divide by 5 to the third power. Simplify that, y to the third power, divide by, and we'll use that again, 5, raise the roof, 3, and I get 125. I'm done. All right, now we're going to do the next one. We have, this one's a little bit more complicated, but we still follow those same properties. I know that I can use the power of a quotient property and rewrite this as 3 to the negative 5 over a to the negative 5. Now, here is the problem. I have something in my denominator that I don't like. I can rewrite that and put it, I keep saying denominator, in my numerator that I don't like. I can rewrite this and put it in my denominator. And this one that's in this denominator, I don't like because it's a negative, so I can put it in my numerator and drop the negatives. So basically, all I did was flip-flop them. These two are literally the same thing. Now that I've done that, I can simplify a to the 5th over, let's find out what 3 to the 5th is, 243. And I'm done. Let's do the next one. And this one is very, very complicated. There's a couple of things here. You need to realize that this has got a negative in it. So watch what I do. This negative 7 is not just going to the 2, but it's going with the negative 2. So I'm going to put it like this. And there's a reason why we do that is because we have to include that negative with the 2. And I'm going to show you in just a second why. And then I'm going to put w to the negative 7 power. All right? Now, let's talk about, before I go any farther, let's talk about the reason here. I'm going to put something very simple. Negative 1 square and negative 1 parentheses square. And I want to compare these two things in my calculator. I'm going to go negative 1, and I'm going to hit the square button, which is here. And I'm going to hit enter. And then I'm going to put it again, but this time I'm going to put it in parentheses, and I'm going to hit that square button. Look what happens. They look like they're identical, but when I put them in the calculator, I get two different answers. Here is the reason why. This square is only affecting the number 1. This square does not affect the negative. It only affects the number it's touching. Whereas in this one, the square affects the entire negative 1. All right, that's the difference. This is actually squaring the negative and squaring the 1 to get a positive 1. So when you're putting these things in your calculator, make sure that you're paying attention. So like for this one, I said that we needed to put it in parentheses. Here was the reason why it's in parentheses here. Now, with that being said, we can rewrite this. We don't like this as this because it's a negative, so what we can do is set it as a fraction over 1 and rewrite it. We know that we can bring that negative 2 to the 7th power down, drop the negative, and we know that we can bring that w and drop the negative on this negative 7. So we're done, over 1. Now let's find out what negative 2 to the 7th power is. Negative 2 to the 7th power gives me negative 128. So this would be 1 over a negative 128 W7, or if we want to simplify it one last time, we could say 1 over 128 W7 and have the negative on the outside. These are the same things. So this one was really complicated because you have to watch this little parentheses. Now, let's do another one. 9. Write an expression using only positive exponents for the width of a rectangle. So go back in your memory and discover how do you find area. The equation for area is length times width. Now, I need to find W, so I can rewrite this equation to say that area divided by length is equal to width. So I've rewrote this equation. Wait a minute. Why did I rewrite the equation? Because it makes my life simpler. Knowing this, I can actually plug this information in. I can say 72 x to the 7th y squared over 24 x squared y to the 3. Now this is where things get complicated. All right. So I've plugged everything in, but how do I go about solving this? This doesn't look like anything we've done before up on top, and you're exactly right. But we still follow principles. Well, check this out. Let's concentrate just on the coefficients. I have 72 divided by 24. Well, let's see what that is. 72 divided by 24. I get 3. So I'm going to write that down. So I've done that. Now let's concentrate on this. I have x to the 7th divided by x squared. Well, that's x to the 7th minus 2 because this is division, and because it's division, we subtract the exponents. And now let's look at y and write it down. We have y squared divided by y to the 3rd, so that would be 2 minus 3. Okay, all of this is equal to w. Now let's simplify this. We have 3x to the 5th, y to the negative 1, all right, equals w. But I don't like that negative 1, so I can rewrite it one last time by imagining this as a fraction and leaving the 3, the x, and the 5 in my denominator because all of this is positive, but bringing the y1 to the bottom into my denominator equals w. So I have simplified the area, and found the width. The width of this is 3x to the 5th divided by y. Now, like I said, that is a lot of information in this thing. And I've done this fairly quickly within about 16 minutes or so, according to my time in front of me. This is just a memorization again. It's just doing this repetitively. So that's what you're going to be doing over the next several days is this type of problems and using these same rules. I would suggest having these with you, but after a while, you don't have to memorize the names, okay? But I do want you to be able to understand the procedures. And I will see you in the next video. Bye-bye.